fine day, you're getting a letter from your boss. Okay. Now what you guys have been assigned is that, say you're maintaining a website called blogger.com. Okay. Now in blogger.com, boss asks you to find out how many times 1 character words occur, how many times 2 character words occur, and how many times 3 character words occur, like that 10 times. Okay. So now this is your requirement. I'll write down what your requirement is. In a website called as some website, you can any website name that you've maintained, what the boss wants from you is that how many times 1 letter words are there, like I, A, such words. Okay, so how many times are these words repeating in my whole blog? My whole blog spot can have, say, 10,000 blogs. In each and every blog like that, I have 10,000 blogs. I want how many times, that is the number, that this 1 letter words are repeated, and 2 letter words are repeated, like is, like this. How many letters like this are there, and how many times are they repeated, like that, and 3 letter words like but, cat, mat, and all those things, like that, till 10 letter words. Okay, so this is my requirement. Or say my website will have, I'm hosting 10,000 blogs. Okay, so an average person, how long would it take, guys? If I give this task to all of you put together, you guys would easily take, including me, if we all were assigned this particular task, we would easily take a month, not less than a month for sure, right? But he says that he is giving you only a week's time, not more than that. Okay, so by a week you need to get this statistics. If you guys have not understood the problem correctly, the output is supposed to be something like this. What the boss expects from you is that he expects the output like this: 1 letter words across all our blogs is this. This number is very much possible, right? 2 letter words across all our blogs is this. Okay, so this is a tedious process, and this is what he's expecting from you. Now how do you go by this? Okay, this is a problem, and let's think of what our solution can be. If you understand what the problem is, then we can go ahead with how our solution can be framed. Okay, yeah, so this is our problem. Now one of you has a brilliant idea. Okay, so you guys are 50,000 in number. Let's assume that you guys are 50,000 in number. Now what you can do is that you are dividing your 50,000 guys into many groups. First group is called mapper group, okay, in which thousands of people are there. The first group is the mappers group, where thousands of people are there. Next group is the groupers. In this particular example, let's assume that there's only one guy. Okay. Now, the third group is that there's a reducer group. Let's assume that, say, 10 of us are there for now. And then finally, there's one master guy. Okay. Say, for now, let's assume that I am the master. Okay. So let's decide into 4 groups. One is mapper, grouper, reducer, and finally the master. Now what I am telling as the master, for those guys in the mappers group, I am trying to tell you guys that every mapper guy would get 50 blogs on his name. Okay, 50 blogs. So 50 blog URLs would be assigned to you. You need to go to each and every blog, like that 50 blogs, and then in a piece of paper, whatever you find, you write that in a certain logic. The logic is this. This is for mappers, guys. Mappers. For mappers, I have 50 URLs assigned per head. Okay. In such a scenario, what I'm asking you, the guys in Mapper, is that you need to go to every URL, you need to hit it, and then you need to consider that the first URL is something like this. The first words in the first blog is like this. Hello, I'm a programmer. Let's consider that the blog starts with these words and goes on and on and on. Now what is expected of the mapper is this. HELLO. 5, hello. 2, I am. 1, a. 10, programmer. So guys, did you understand what the mapper is supposed to do? He has to first write the number, how many letters the word contains, comma, and the word itself. Okay, so like this, he needs to write for the entire blog. Like this for all the 500 blogs. Guys, did you understand the function of mapper? What he's been assigned by me? The task which he needs to do is that in a blog, for each and every word which he sees, he must write the number of letters in that particular word, comma, the word itself. Like this he needs to do for all the 50 URLs that he's been given. Now let's assume that this activity goes on for 4 days. Now what the grouper does is, I'm going to give grouper only 10 sheets of paper. Okay, I'm going to give the grouper 10 sheets of paper along with the output of what the mapper guys have given me. What the mapper guys have given me, they've given me a lot of papers. Each paper would be having the data like discussed above, 5, hello, 2, I am, like this. Now what the grouper is supposed to do is that he is supposed to take only 10, that is, I'm going to give him only 10 sheets of paper, and the first sheet would be marked 1, the second sheet would be marked 2, third sheet would be marked 3, and like that till 10. So 10th sheet would be marked 10. Now the first thing he needs to do is that take the sheet of paper which says 1. Okay. Now he takes a sheet of paper which says 1, and in that first sheet of paper he will write something like this. What the output of mapper has been something like this, right? 5, hello. Now from this, using this sheet of paper, the grouper is supposed to write like this. In the sheet paper 1, he's supposed to write like this. A, I. So this is what he's supposed to write in 1. Got it? Now in sheet number 2, this is what he's supposed to write. All the 2-letter words which is found in the output of mappers. Is what are words there? It's okay for now. So like this he has to write for second sheet of paper. So like this he'd be getting 10 million words, like this he'd be getting another 10 million words. Now for this, same thing. In the third sheet of paper he is supposed to write like this. But, cat, mad, rat, bat, like this. So this sheet will go on and on. So the first sheet will have all the single letter words. The second sheet will have all the double letter words. The third sheet would have all the 3-letter words. Okay, the fourth sheet would have all the 4-letter words, and so on and so forth. Now post this, what the grouper does is that he gives it to the reducer. Okay. Now initially how many sheets did the mapper guys have? They had a lot of sheets, because each guy had to take care of 50 URLs and I had 1,000 of them. So it would be like 50,000 sheets. So of the 50,000 sheets, what this guy grouper has done is that he's used only 10 sheets. Okay. So first sheet is only for 1 letter, second sheet is for 2 letters. Like that he has sorted things out. Sorted things out. Hear these words, guys. Sorted things out. Okay. Now this guy, he is given these 10 sheets to the grouper. This grouper has given these 10 sheets of paper to the reducer. Now how many reducers do I have? 10 reducers. The function of reducer is to count each and every reducer would be given one sheet. First reducer would be given sheet 1, second reducer would be given sheet 2, third reducer would be given sheet 3. So 10th reducer should be having sheet 10. Now the function of the reducer is to count the number of sheets in each and every paper and write it at the back of the sheet. Simple. Okay. So the reducer number 1 will count like this: 1, 2, 3, 4, 5, 6, 7, 8. So we write 8 at the back of the sheet. Now this is just an example, but when you're talking about a huge data like our case where we have 50,000 URLs, just imagine how many words would I be getting. My number of words would be something in the order of this, right? So these many words at the end of sheet 1, at the backside of sheet 1 you would be writing. So reducer 2 would be writing a similar number at the backside of sheet 2. In a similar fashion, sheet 10, till sheet 10, this is how the words would be written at the backside of each and every sheet. Now this activity can be completed in not more than 5 or 6 days. So when your boss comes back and asks you, guys, it's been a week, now is my data ready or not, then you can as well go ahead and show it to him. Okay. Now at the end of this, what you guys have done is effectively called as MapReduce. Welcome, this is MapReduce for you. This is the simplest possible thing, right? This particular problem, when I have 50,000 URLs, would not be possible other than any other method other than this, right? This method is the simplest possible one. I have 3 groups: the mapper, the grouper, and the reducer. Now the advantage of this particular method is that the mappers can work independently. They don't need to rely on anybody else. One mapper does not need to rely on another mapper, right? I can do my work. Whatever the 50 URLs have been given to me, I can do it at my given time. I don't need to rely on someone else's work. I don't have any dependency of any other's work. So the mappers can work independently. Next, reducers can work independently as well, because post what the grouper has done, each and every reducer is getting an individual sheet of paper. Now he also does not rely on anyone. He does not even need to know that there is another such reducer like him. Right? So he can just go ahead with his own work. Post his completion of work, he can inform the master saying that, master, I'm done. The third advantage is that the grouper can work really fast, right? Why can he work really fast? Because he didn't have to do any of the counting. He just had to group it. It was not a brain work. It was just a eye-hand coordination and hand-eye coordination rather. He would see the output of the mapper and he would just write it in a piece of paper. That's all. He did not have to count any of the words. Had he had to count, it would have been a pain. So all that he had to do was to look at the first number and put that word in the appropriate sheet. That's all, right? So it was simple. This is the advantage of MapReduce. Each and every guy does his own job quietly. There is no dependency at all. Okay, so this is the takeaway, that basically we will be having 3 groups. Okay, now let's get into a little bit deeper. Okay, so we have something called as a map class, a reducer class. I'm not saying that there will be only one class, but there might be thousands of classes, but there would be mapper classes, there would be reducer classes, and if you want, you can have grouper classes as well. Okay, so we can have 3 guys. Okay, so if we have 3 guys, we can finish off our work a little faster. Okay, so even in real scenarios, the output of a mapper, what you've seen is that 5, hello, 2, I am, 1, 10, programmer. All these things, if you can see, if you can associate it, it is in the form of a key value pair, right? Value is the word which is already there, which it is taken from the input, whereas key is something which I assign, which the mapper assigns, right? So 5, hello is basically a key value pair where the value is hello and key is 5. The value hello is taken from the input of the file, and 5 is something which I am assuming it, I am giving it based on my logic. And the grouper would be sorting things out, would be combining things out, and it would be passing the output to the reducer. Now the reducer would again do the downward integration, that is from many sources to one source it will reduce it, okay, and it will give the final output in quick time, in very quick time. Job tracker and task tracker. Now when I use these words job tracker and task tracker, these words are associated only with MRV1. Guys, please mind it, MRV1 is for MapReduce version 1, okay. Till now, till date, this is the most stable version. This is what the world has been using it in critical systems, okay. So job tracker and task tracker, where job tracker is the master and task tracker is the slave. So job tracker assigns the task to the task tracker, okay. So the task tracker runs many jobs and gives the status to the job tracker. Again, the communication between job tracker and task tracker is through heartbeats.